Hey guys, it's Jaden, and today I'm going to be showing you how to do a chi-squared analysis. This was one of my favorite subjects during biology because it has to do with math, and algebra comes easy to me. Chi-squared analysis is a statistical form of analysis used to compare the actual or observed results with the expected results. By calculating the chi-squared value, you determine if there is a statistically significant difference between the expected and actual values. This is going to be your observed value. Say we find out that both of the parents are heterozygous. By doing a Punnett square, we can figure out that the expected values are to be 75 tongue rollers and 25 non. Here are your expected and observed values. The next step is to calculate your chi-square. Chi-square is your observed minus expected value squared and divided by the expected value. Chi-squared is the sum of these. If your actual and expected values are the same, then chi-square equals 0. If the observed actual and expected genotype frequencies are the same, then the population is in Hardy-Weinberg equilibrium. In this situation, we observed 90 tongue rollers and expected 75. We observed 10 non-rollers and expected 25. This leaves our chi-square value to be 12. The next step is to find the degrees of freedom. Degrees of freedom are the number of phenotypes or genotypes or categories minus 1. So in this case, because we have two categories, tongue rollers and non-tongue rollers, the degrees of freedom is 1. Using a chi-square critical value chart, we'll find the critical value for 1 degree of freedom. This is 3.84. Next, we will determine the p-value using the same chart. We know that chi-squared equals 12, the critical value is 3.84, and the degrees of freedom is 1. Using the chart, we will know that the p-value has to be less than 0.001. Once you found the p-value, biologists generally reject the null hypothesis if the p-value is less than 0.05. Because the p-value is less than 0.001, the experimenter must reject the null hypothesis. What does it mean to reject or accept the null hypothesis? Accepting the null hypothesis means that the results from the experiment differ from the expected only by chance. The next step is to write your conclusion. If your chi-squared value is greater than the critical value, then there is a significant difference. If your chi-squared value is less than the critical value, then there is not a significant difference. In this case, our chi-squared value equals 12, which is greater than our critical value of 3.84. This means that there is a significant difference in expected and observed values in this case scenario. And that's a simple breakdown about how you complete a chi-squared analysis.